Hi again, welcome back. I'm Mrs. Burns and we are on lesson 3 of our chemistry unit. Today we will be talking about Lewis diagrams. So we've already talked about the periodic table and Bohr diagrams, and we know that the periodic table shows the patterns of electrons in atoms. So our big idea questions today will be, how are these electrons arranged in the atoms versus the ions? So we talked about atoms and ions the other day, but let's dive in a little deeper. And then also, how do you know what elements are likely to bond together? What bond is going to form here? Is it going to be ionic bond or a covalent bond? So this handsome guy, Gilbert Lewis, he was an American chemist that was known for his discovery of the covalent bond. In 1923. He was so smart, he got his PhD when he was 24. That's awesome. Now he invented Lewis diagrams, which can also be called Lewis structures or electron dot diagrams, and these show how many electrons are in the valence shell of an atom. So what's the difference then? Bohr diagrams, Lewis diagrams, why are we learning all these different ones? Well, there are different ways to express the electron arrangement. So you'll notice here the other day we talked about Bohr diagrams, and we have the first electron shell with 2 electrons, and then subsequently we go into the next shell. Once it fills up with 8, we go into the next shell, and we draw all of these shells as well as the protons and neutrons in the nucleus. Now these 6 electrons, these 7 electrons, and this 1 electron, these are the valence electrons, and we show each shell. Now in the Lewis diagrams, you'll notice that here we only show the dots for the outer electrons only. So 6 valence electrons only are shown. So we skip the step of all those little mini inner shells. So remember that for a neutral atom, the number of protons, and I'm just going to write P here, is equal to the number of electrons. Protons are positive and electrons are negative. So for example, if oxygen has 8 protons, it has 8 electrons. 2 are in the first inner shell, so 8 minus 2 leaves us 6 electrons in the outer valence shell. So for oxygen, if we're going to draw just the outer shell, we know there's 8 electrons, but 2 are in this first shell, so there's only 6. We're going to go around like a compass. So remember, compass, north, east, south, west. And we're going to go in a circle. You can go clockwise, you can go counterclockwise. You can start at any point as long as you keep going in the same direction. So 1, 2, 3, 4. Now keep going in the same direction. 5, 6, and we stop, and we see that 2 sets of our electrons are in pairs, and then 2 electrons are singled out on the 2 sides. Now, how do you know how many valence electrons are for each different element? Well, let's have this handy dandy table to show us. In group 1, they have 1 valence electron. Group 2, 2 valence electrons. Group 13 has 3 valence electrons. 14 has 4 valence electrons, 5 electrons, 6 electrons, 7 electrons, and the noble gases have 8 valence electrons. So we know that when they have 8 valence electrons, this is very stable. That's great. They're not going to react with any other elements because they already have the 8 in their outer shell that they want. Or in the case of helium, it has 2. Now, the other atoms will want to make sure that their outer shell is stable. So the most reactive will be here group 1 and group 17. These are very unstable. Now groups 2, 13, 14, 15, and 16 are also unstable, and they will want to react as well, but they're not as reactive as those in group 1 and 17. So let's put this in words here. Group 1, the alkali metals, and group 17. The halogens are extremely unstable. They will react with other elements very easily. Group 18, noble gases are very stable, and thus will not react because their valence shells are full. So let's draw sodium and do this little example here. Sodium, we see, has 11 protons. So this is our atomic number. Hopefully you have this memorized. If you don't, you should memorize this. This plus, sometimes a minus, sometimes it has a number in front of those pluses and minuses. This is the ionic charge. And the number here at the bottom is the atomic mass. And then we have our symbol in the middle and the name of our element. So if we were to talk about the protons, neutrons, and electrons of this atom, we can figure it out just based on this little box. So the protons is the same as the atomic number, so that's 11. The neutrons is simply the atomic mass rounded to the nearest whole number. So here we have 23.0, it'll be 23. But if you have, say, 27.8, then you'll bump it up to 28. So you're going to say the atomic mass minus the atomic number equals your neutrons. In this case, we have 12, and the electrons in an atom are the same as the protons. So a Bohr diagram, we would draw 11 protons, 12 neutrons, and then we would go around in each of the shells and say, okay, 2 in the first shell, we're going to do 11 altogether, 3, 4, 5, 6, 7, 8, 9, 10, oh, that's 8, next shell, and 11. So that's a lot of drawing. So instead of doing all that for the Lewis diagram, you only need to count the electron in the outside shell. So we draw the symbol, and then the one electron, you can put it anywhere you want on the north, east, south, or west side of the sodium. Atoms and ions are different. Remember that if we're drawing an ion, the number of protons does not equal the number of electrons. So our sodium atom as a Lewis dot diagram versus sodium ion, we've just gotten rid of that electron. How do we know? Well, because the ionic charge is plus. So that means that there is one extra proton, then there are electrons, so it got rid of that electron. So no electron. But instead of just drawing Na all by itself, we say that it has one plus. So they got rid of one electron, leaving it one extra proton, then electrons. Now you see that there are no dots around this Na. We don't show any dots because no dots, no electrons in the valence shell. So the one dot was in the valence shell and it got transferred over somewhere else. So now there are no electrons in the valence shell, so we don't show any. So atoms want to have a full outer valence shell. They may transfer, as we just saw in this example, or they may share their electrons. So transferring, we'd call this an ionic bond, and sharing would be a covalent bond. So let's talk about these ionic bonds again in terms of Lewis diagrams. Ions indicate that there's been a transfer. Remember that only the electrons are going to move. So the protons are stuck in the middle in the nucleus. So when the ion is positive, this tells us that the electrons have moved out. And when the ion is negative, it means that electrons have been transferred in. We've added more negatives. Ions will form when a metal cation transfers its electron or electrons to a non-metal anion. Let's take the case of lithium and chlorine. Here we see that lithium has 3 protons. 7 minus 3 protons is 4 neutrons, and same amount of electrons. Protons here for chlorine, 17 neutrons is 36 minus 17, that gives us 19, and electrons are the same. So if we draw our lithium, we have 2 in the first shell, then only 1 in the outer shell. And chlorine has 17, but we know chlorine only has 7. 1, 2, 3, 4, 5, 6, 7. Now a quick reference to know would be figure 4:12, and this tells us, remember, how many valence electrons are in each group. So that's a quick reference to see just how many electrons are surrounding each element. So lithium has 1 here, and chlorine has 1, 2, 3, 4, 5, 6, 7. So this lithium is going to be transferred over into that vacant spot, and lithium is going to be left as 1 positive. Chlorine is going to have 1, 2, 3, 4, 5, 6, 7, 8 full electrons, and it has 1 extra electron, so we say 1 negative. Now you'll notice again here, this lithium has no dots around it. It is stable with 2 electrons in its first shell, and chlorine is stable with 8 valence electrons. All right, on to covalent bonding. Unpaired electrons from different atoms can share, and we call these bonding pairs. And this will occur between 2 nonmetals. This can even occur between 2 nonmetal atoms that are the same. For example, oxygen atom and oxygen atom can come together to make oxygen O2. So hydrogen, 1 proton, 1 minus 1 equals 0 neutrons, 1 electron. So we are going to show just that 1 in the outer shell. Fluorine has 9 protons, 9 electrons. 19 minus 9 neutrons is 10. Fluorine will have 9 minus 2 electrons in its first shell, so 1, 2, 3, 4, 5, 6, 7 electrons in its valence shell. So let's draw it here. Hydrogen is 1, fluorine is 1, 2, 3, 4, 5, 6, 7. The hydrogen atom will send 1 electron over, but he doesn't get rid of it. They are going to share that bond. So this electron moves over here, and it forms a bonding pair. So both hydrogen and fluorine share that pair. Fluorine also has its other pairs around it. So we see that hydrogen has its 2, and fluorine has its 8. So that's very convenient for both of them. That bonding pair can also be indicated as a line, and then we draw the extra dots around the fluorine. So the bonding pair can be drawn as a line or as 2 dots, and our hydrogen is stable with 2 valence electrons and our fluorine is stable with 8. Hooray! On to our last example, oxygen and oxygen. They have 8 protons. 16 minus 8 is 8 neutrons, 8 electrons. So the Lewis diagram for oxygen would be 8 electrons, but 2 are in the first shell, so there's only 6. 1, 2, 3, 4, 5, 6. Same with this guy. 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So one of these free electrons is going to form a bonding pair with that other one. So we'll show that bonding pair in orange here. And then the other free electron will come and share a bonding pair spot with that free electron. And this forms this bonding pair. And then we're going to spread out the remaining 4 electrons per oxygen so that they're stable. So let's draw them 1, 2, 3, 4 like so that everything is nice and balanced on top and on the bottom. Now we can see that this oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons, so it's happy, and this oxygen has 8 electrons, so it's happy. We could also draw those 2 bonding pairs as lines. Remember that one line indicates 2 electrons, and then we'll draw our extra dots surrounding it. So each oxygen here now has 8 electrons in its outer shell. Now you know how to draw Lewis diagrams. So tomorrow in class we will be discovering this idea a little bit further, and then in class we will dive into some more of the details in the similarities and differences between board diagrams and Lewis diagrams.